Welcome to session 4. It is now time to learn how to create servers. To be clear, there are three main parties involved in digital platform architectures, aka websites. There's a server, which hosts the website and makes it available to everyone online. Clients, which come trying to access the website on their own personal computers. And a database, which stores dynamic data types, something we'll cover later on. Regarding servers, there are three main components: request, deserialize, response. We're going to go through this list twice, the first time around in the form of GET requests. GET requests are fairly simple. When a client tries to access a web page via their browser, the client effectively makes a GET request to the relevant server asking for data, the thing that you end up seeing, back. Okay, so we're going to start with a boilerplate. Boilerplates are basically default schemas that are commonly reused every time you start a project. You don't have to understand what any of this means yet, because we'll go over them step by step. Now, the server needs to process GET requests, and we can do that with this line here. Thus, every time someone tries to access website name / profile page, we then send them the folder name profile page, located in the same directory that the source folder is in, and open profile page.html, which then makes references to its associated CSS and JS files. Here you might be asking yourself, what are HTML, CSS, JS files? These are file types associated with what web developers call client-side code as opposed to server-side code, which is what we're looking at right now. HTML is simply a way to represent text on websites. CSS then stylizes these texts. Finally, JS is what allows websites to have functionality. We will go over these in more detail later, but for now, we just have to be able to know how to create these folders and relevant files. As well as how to create new web pages, which we can do by just adding a line here, like so. For now, you can just think of this folder as one of the web pages we can later then send to clients. Next up, we have post requests, and this is the second time around that we're going over the request to serialize response architecture. In short, sometimes the client might be the one that needs to send data over to the server, so that the server then processes the information before returning that data back. Technically, these aren't really used for static websites, which return the same info back every time it's loaded, and are more so for dynamic web pages, which vary in their output, as in the case of social media. Databases often being required also. But this is still important to know if you ever intend on collecting data, such as in the case of completed form submissions. It's quite simple. In order to receive the signal, we just need to add this line .root parentheses right here. Which then makes it so every time someone makes a post request to website name / profile page, we trigger the profile _ page function. We just need to make sure we process the data in the case of it being JSON, or as we know them, structs, via the serialize so that we can access them later via info. within this passage before we run the code and return a response back. More specifically, JSON is being processed as a struct before it is made available as info. This line here is just there to make sure it processes alright within internal bracket clauses, such as in the case of statements, if else, or for while loop. TLDR. To summarize, when a person goes to the website name/profile page, it makes a post request. They trigger this function, which then links the JSON as info after being deserialized as a struct here. Meaning, these subvariables in the struct profile can then be accessed via info dot as listed, like so. This is assuming, of course, that the client is making a post request with JSON under these values. You might then ask, how can we ensure this? Actually, the specifics of how post requests are conducted themselves are often based on JavaScript functionalities inside the JS file that were initially transferred via a GET request when they first load up the page. In this way, we establish communication. The important takeaway here is now we can transfer data from server to client and client to server. That concludes server side for now. Next session, we'll actually create some websites, returning back afterwards to server side for projects requiring databases.